Okay, so what we're gonna do now, alright, is okay. So imagine you've got a cylinder, okay? The volume of that cylinder, oops, the volume of that cylinder, come in, it's fine, just stay here. Where's the pen? Okay, well, the volume of the cylinder, actually, volume of cylinder is pi r squared h. Okay, let's say the volume is 20 meters cubed. Let's say the volume is 20 meters cubed. So that means 20 equals pi r squared h. Fair? Fair. Okay, the surface area of that cylinder, you good? Yeah. The surface area of that cylinder, okay, the equation for that is, if I'm not mistaken, 2 pi r, yeah, 2 pi r squared plus 2 pi r h, okay? Now, if I want to ever find out the rate of change of this, or like, if I want to differentiate this equation, it would be wise to get everything in terms of r, okay? It just makes life a bit better, okay? For partial integration reasons, differentiation reasons. This h here, okay? If I go back to this original equation and make h the subject, I get 20 over pi r squared, okay? So that means I can rewrite this and say 2 pi r squared plus 2 pi r bracket 20 over pi r squared, okay? Remember that is also 20,000 liters, just so you know. Okay. Now r and r squared, well, the square cancels, pi and pi cancel, so I'm left with 2 pi r squared plus 40 r. Okay. Or I can call that 2 pi r squared plus 40 r minus 1. Okay. So what we have is 2 pi, so this is the surface area, 2 pi r squared plus 40 r minus 1. Okay, now if I differentiate it, okay, dA over dr, I'm going to call it A instead of dSA, I can't be asked. Alright, dA is cool enough. So differentiating the area in terms of the radius, okay, well, what I get is 4 pi r plus minus 40 r squared. Yes, minus 40 r squared. Sorry, minus 2 there, okay? And I can rewrite that like this, okay? Now, this is your differential, this is your differentiation done, okay? But we want to take it a step further. Let's find the maximum or minimum, okay? So max min solution, okay? So we make the differential sign equal 0 and we begin to solve for r, okay? This is why we made h at the start, because now it's easier to kind of, we got rid of h, it makes life easier now here, because we only have one unknown, which is just r. And if we rearrange, okay, we rearrange for r, what we'll end up getting is r equals 3.18 meter. Okay, when we plug it in back into the equation for h, which was 20 all over pi r squared, we get h equals 0.629 meters. So now we've got h, now we've got r. Okay, job well done. Alright, what's up? Oh, thank you.